Hello everyone, I'm Vishwa Jasekara and my index number is 20APC4674. And today I'm gonna present you about software design patterns. So first we'll talk about what is a design pattern. Design patterns are essentially best practices or proven solutions to common problems that software developers encounter. Think of them as templates or blueprints that provides standardized way to address recurring design issues. So there are mainly three patterns in these design patterns: creational patterns, structural patterns, and behavioral patterns. We'll talk about these three patterns one by one. First, creational patterns. Creational design patterns that focus on instantiation can be divided into two types: class creation patterns and object creation patterns. Class creation patterns use inheritance to manage instantiation process efficiently and creating a structural hierarchy for classes. On the other hand, object creation patterns employs delegation, handing off the creation responsibility to other classes or methods for greater flexibility and decoupling in the code. So these are some examples for creational patterns: factory pattern, abstract factory pattern, builder pattern, object pool pattern, and singleton pattern. Next, we'll talk about structural patterns. Structural design patterns focus on class and object composition. Class creation patterns use inheritance to combine interfaces, creating new structures, and also object patterns defines methods to combine objects, enabling new functionality and enhancing flexibility. So in here also there are a few examples we can say about these structural patterns: adapter pattern, bridge pattern, composite pattern, decorator pattern, and proxy pattern. Next, we'll talk about behavioral patterns. Behavioral design patterns focus on how objects communicate with each other. These patterns are specially concerned with defining effective interactions and responsibilities between objects. They ensure that the communication is clear, manageable, and also scalable in software systems. We can give a few examples for behavioral pattern as well: chain of responsibility pattern, command pattern, iterator pattern, memento pattern, and null object pattern. So let's next I'm gonna give you a live demonstration on these patterns and real world examples for these three patterns. First, I'm gonna present you about the singleton pattern. So here, as you can see, the configuration manager class implements the singleton design pattern. This pattern ensures that only one instance of the class exists throughout the application's lifecycle. The class contains a private static variable instance type of configuration management manager. This variable holds the single instance of the class. The constructor is private, which prevents other classes from initiating the configuration management manager class directly. Inside the constructor, a message indicating the loading of configuration settings is printed. In the real application, this is where configuration settings would be loaded from a file or another source. The next, the get instance. The get instance method is a public static method that provides access to a single instance of the class. If the instance is null, it creates new configuration management manager object. Otherwise, it returns the existing instance. Next, the get config value method is a public method. As you can see, public method that takes key as a parameter and returns configuration value. As you can see the configuration value. For demonstration purposes, it returns a hard-coded value, some value. The singleton demo class contains main method, as you can see here, main method, two variables, config manager 1 and config manager 2, are created by the calling configuration management dot get instance. Since configuration manager follows the singleton pattern. Both variables points to the same instance. The get config value method is called on configuration management 1 with the key example key. Here you can see the example key, and the result is printed. The code then compares configuration management 1 and configuration management 2 using the using this parameter, this operator, which checks if both references point to the same object. Since configuration management configuration manager is a singleton, this comparison will return true. We'll see the results. Here you can see the result is true. So next, I'm gonna demonstrate about structural pattern, and I choose decorator pattern. So let's move on to the this code. The code illustrates the use of decorator design pattern. This allows behavior to be added in an individual object dynamically without affecting the behavior of the objects from the same class. The example involves simple noodles dish that can be decorated with additional items like sauces and drinks. In this component interface, the noodles interface defines the method that any noodle related class should be implemented. It has two methods, as you can see, get description and also get cost method. In here, the get description method returns a description of the nodes, and also returns the get cost returns the cost of the noodles. Next, let's move on to the concrete component. The simple noodles class implements noodle interface. It represents basic noodle dish with fixed description, simple noodles, and the cost $7. Next, you can see the noodles decorator abstract class. Here you can see the base decorator. The noodles decorator class implements the noodle interface and serves as the base class of all decorators. It contains reference to a noodle object. Here you can see the decorated noodles and which it wraps. Next, move on to the constructor. The constructor takes noodles object and initialize the decorated noodles field. Here you can see the methods. The get description and get cost method simply delegates the call to the wrapped noodles object. Next, we'll move on to the sauce decorator class. The sauce decorator class extends the noodles decorator and adds sauce to the noodles. As you all know, we can't eat noodles without the sauce. So the constructor calls the superclass constructor with the noodles object to be decorated. The and also we can talk about the methods we have used. The get description method and also the get cost method. Those are as usual. Next, we can move on to the drink decorator class. Here, the drink decorator class extends the noodles decorator and add a drink to the noodles. The constructor calls superclass constructor with the noodles object to be decorated, and also same methods. Next, let's move on to the decorator demo class. The main method of this class contains main method, and also it demonstrates the use of the decorators. First, it creates the simple noodles object, and prints its description and the cost. Then it wraps the simple noodles object with sauce decorator, sorry, source decorator, and the source decorator prints the updated description and cost. Finally, it traps the decorated noodles with drink decorator and print the final description and cost. So that's all about decorator demo. And let's move on to the final final pattern, the behavioral pattern. And I chose strategy decorator. I'm so sorry, I forgot to run this code. We'll run and see the output. As you can see, it first prints the simple noodles and $7. Next, simple noodles adds the sauce and the cost, implemented cost, and also finally, noodles, sauce, and the drink. So let's move on to the strategy demonstration. Here, the code demonstrates the use of strategy design pattern. The pattern defines the family of algorithms and encapsulates each one and makes the interchangeable. The strategy patterns lets the algorithms vary independently and from the clients that use it. In the example, different payment methods are used in a shopping cart context. So first we can see the strategy interface. The payment strategy interface defines the method that all payment strategies must implement. Next we can see the concrete strategy for credit card payment. The credit card payment class implement the payment strategy interface for the credit card payments. It has a private field called card number. Here you can see the card number. And next we can see the constructor initialize the card number field. So there's the method. The pay method prints the message indicate the amount paid and with the credit card showing the last four digits of the card number. You can see the last digits of your card number. Next, concrete strategy for PayPal payments. The user will be able to pay with the PayPal as well. In here, the concrete strategy class implements the payment strategy interface for for the PayPal payments. It has a private field email to store PayPal account email. Of course, we have to provide user with their PayPal email. The pay method prints message that indicates amount paid using PayPal account. Next, we can see the context. The shopping cart class represents the context of which payment strategies are used. In fields, it has a private field payment strategy to hold the current payment strategy. Here, the set payment strategy is a method sets current payment strategy, and the checkout class checkout method uses the current payment strategy to process the payment. If no strategy is set, it throws an illegal state exception. Here you can see the main method. The strategy demo class contains main method which demonstrates the use of different payment strategies in the shopping cart. It creates a shopping cart object. And also here you can see the it sets the payment strategy to a credit card payment with a simple card number process a payment of 100. It changes the payment strategy of PayPal payment with a sample email process a payment of 200. So let's run this code and see the output. Here you can see I have paid 100 with credit card ending 5678, and also 200 with with this email with using the PayPal account. So that's all about strategy pattern. I hope you got an idea about these methods from my presentation. Thank you so much for listening.